Hello there, once again. I am Al, and probably nobody's watching this. Just having a look at the view counts here. A whopping 2 views of the last one, and nobody was interested in the puzzle. And inheritance seems to be not something anyone is interested in hearing about. However, I should mention, for the person who's following this, for that one special person, or maybe two, if you inherit from a class, if one class inherits from another class, and that other class has a constructor that might take some arguments, and you want to invoke that particular structure for your class, I'll give an example. This is my struct, and suppose it they say derives is another way to say inherits from. And suppose this other struct has a constructor, let's say taking some arguments, maybe a couple ints. And maybe it does something with that. In your class's constructor, if you declare one of your constructors anyway, if you declare your constructor this way, with nothing specified, then that's going to invoke the default constructor, whether it exists or not, of this one. And I'm going to prove that first. So if I declare a my struct and don't do anything in my constructor, or I don't even have a constructor, this line will be executed. See? We printed that out. Whereas this other one, well, it doesn't do anything. Let's make it print something out too. Unfortunately, this function thing doesn't give you the full name. There's another one like this that gives you the mangled name, but then you have to figure out how to unmangle it. But I'll just unmangle it by hand. So again, nothing. In fact, to make it even more clear, okay. Now, if I want to invoke, in particular, the constructor from this that I want, I can by putting by declaring here which and invoking the constructor of this that I want in particular. And if I want this one, I would have to supply 2 integer arguments. So I could say 2, 3. No, I could actually print out the values to make sure that that's what we get. So this here tells the compiler that in order to build this structure, I would like to invoke this particular constructor of the parent class, often called the super class. So as you can see, this one got invoked rather than the other. So that's something that you should be aware of. Similarly, if there were more things along here, you can specify them along here. It's also worthy of note that, disregarding inheritance or anything, if you have members in your class and you want to initialize them, they can be initialized in a similar manner. For instance, J could be initialized rather than in the function's scope. It can be initialized by putting a colon and then specifying the name of the thing you want initialized, and then brackets and the value that you want to initialize to. For instance, if I had a string, I could add that to this list here, and it will be initialized with that value. And you'll see that it compiles fine, and it's set to that value. You can't put an equals sign or anything like that here. That's not allowed. It has to be something that can be put in brackets. Okay? Alright, that's the note I wanted to get out of the way. And the topic, though, in this tutorial is going to be, or is starting to be, what are called pointers to members. So again, starting with some struct, name, it might have some members. I don't know if you can hear that chanting in the background by those monks. It's driving me crazy. You'll notice the time. They started doing that at 5 a.m. Okay, let's say you have an integer in here, an integer member, I1. I usually like putting a little m and underscore in front of members. That way, there's two reasons for that actually. One is it helps you see when a variable is a member, right? And two, in a constructor declaration, let's suppose you had two members with similar names, and a constructor which takes values with similar names. This is kind of like that rect thing. It tends to be easier to write down this sort of thing. Oops. You see, it's clear which one's the member and which one's just the value being passed in. So that's something you might want to get into, that habit of putting it. If it's not an M, some people use just an underscore in front. You know, something to indicate that the value is a member of, rather than just a plain old value of the struct. Now what I'd like to show you is if I had such a struct, how do I suppose I want to declare a variable name that points to one of S's members. So either a pointer or a reference that points to this or to this. What is the syntax for that declaration? And there is a specific syntax to do that, and there's also one for member functions. But first, let's just look at a new, like a data member. And the first part, like in any declaration, now this, if we're going to talk about a thing that's a member, we need its type, which is an int. Now it's going to be a pointer to an int. So somewhere there's going to be a star. Somewhere. Now, we need to be able to tell the compiler that this object is within the scope of a myStruct object. So now we also need to supply a name. So the syntax is like this. First, the name. Oh, hang on, I can't remember now. This is that. Okay. I kept getting all these errors, but in fact, it was this. I wasn't able to read them. I was missing a semicolon here. This is so this is a declaration as a pointer to an integer member of my struct. I haven't given this a value yet. All right. So this is just a declaration. I can make this a type def if I want. And that would be a way to define something of type P, member of my struct. Should compile. Okay, now how would I set that equal to one of these values? Well, again, it's one of these syntax things. I can declare a PI now. That doesn't look like much of a type. P myStruct. Now I can declare a P myStruct int and give it a name. The value. And now I got to set this equal to something, and this part is actually quite easy to remember. You just take the structure name, double colon, and give it something like this. And now it has to be the address of that. Okay. Yeah, that should be okay. Alright, now that is a pointer to a member, pointer to this member, but of what? How do I use this thing? This is still not a very good, I should say, P member. Member. myStruct. I want to emphasize the fact that this is not actually a particular value. In order to find out, now it's raining, of course, drowned out the monks, but now I can't hear anything else. In order to use this P as a value, I would need a myStruct. So for instance, in order to find out what the mi2 value of s is, I could use s. So there's two ways to do it. For one, shouldn't be here. I can say S. So this is the invocation part of accessing a struct member value through a pointer to member value. And the way that works now, essentially this is an offset. And what I need to do is use a special new keyword. Since this is not a pointer itself, but this is a type of pointer, I use that dot, but now I have to dereference a pointer, star, and then use this thing that I've named. So that should compile, believe it or not, and that should give us the number 3. You see? Now it's hard to step through that, but looking at the disassembly clarifies things a little. First, we're putting, what it's putting into key the value is the number 4, okay? Now 4 is simply the offset of I2 within that struct. So key the value is equal to 4. And now it's loading into ECX, S, the address of S. S is our thing on the stack here. This is strange notation. Keyword pointer. S of EAX. Oh, I see. So it's S offset EAX. So basically this is S plus 4. We go to is wherever S is. We have the registers. I'd like to stop on this line. Alright, now S here, although we don't know its value yet, AX is 4. Now this should just be the pointer to S plus 4, I would think. Oh, no, I see. It's dereferenced that. So it's taken S, which I don't have the address of, but I can get it. This is that. Now I need memory. And I can move that over here. Just keep that together with this one. Alright, now this was, it turned out the address of S, in which there is a 2 and a 3. And offset 4 is a 3. So this value is this funny number, and you add 4 to that, you will get this address. And unfortunately, the disassembler doesn't show us. The disassembly doesn't expose the value of S, because this particular sequence of instructions is highly efficient. I don't think Okay, well, that helps. So EBP minus DAX4 minus 0C. So that's the first thing on the stack. EBP minus C is the address of X plus EAX, which is 4. Load that into this value I, which is this thing, and the answer comes out 3. Now, that's a very strange thing. In fact, this is considered as one single operator, okay? You couldn't write this. That won't compile. You get an error, I hope. Yeah, error. I'll bring this down here now. Error bracket. Well, here. No, I can't believe it. Thing. Alright. This is sort of what we had. Error bracket. This thing, these go together. At dot star, okay? So it's like a single unit, and this is how you dereference a pointer to member. Now, similarly, if S here was a pointer, suppose we had a pointer to a my struct, PMS, address of S, okay, that's a my struct pointer, okay. In order to retrieve the same value using the pointer thing, we use another new operator, and that's arrow star. And again, this is one unit. This is considered one operation. It's not arrow and then, this being some separate value on its own. The whole thing is, this whole thing, I don't know if I can do this, I doubt it, maybe, no, can't do it. But the whole thing is one value, or one operation. Now I think this takes precedence over other things. Certainly, if this were a pointer, like I'd have to make a new pointer. I want to use new, but I haven't told you about new. But I can create new. That's new. That's as good as new. That's good as new. Oh dear. I'm missing a parenthesis. Yeah. Okay, pointer to int, malloc 1 int. So now this here pointer is a valid pointer we can dereference. So now the type here has changed. This is an int star. Okay, so this assignment should this should be okay now because the type of this is the type of thing that we want. And what have I done wrong here? I2 is unused, true enough. I can set it. Yeah, but I got an error of some sort. Missing a semicolon. Yes, true. Cannot convert from int star to int, and that's true. This thing is not an int anymore, it's an int star. We could call it pi. But this part should be the same. All that's happened is I've just changed the type of this member. Now the question is, if I wanted this to be an int, and I put a star here, what takes precedence? Well, what I would say is, before figuring out what the answer is, you should never have to ask yourself that question, because you can always put brackets around. Okay, now it's obvious what takes precedence, but let's see if this compiles, and I think that you'll find that, yeah, star here, it turns out, has the highest precedence of all operations. So by putting a star here, that's like doing this. And that's not what we want. What we want is this. And now it's okay. Now we should get our 3 back. Let's make it, well, we pass it in as 3. Sorry. Stop. Try again. It's 3 again. Why have I got more threads? Where's local done? Oh, that's okay. Locals, okay. So it is 3. So you see that this part, this being a pointer, has to do with the type of the member type. This here is a type that is a pointer to a member, which could be of any type, we specified here. And this is how you declare a pointer to a data member in a struct or class. Class works as well. I'm going to make these public. And class and struct is the same thing as I told you before. Now, let me check my time. Oh, okay, so that's long enough. And now I'm going to show you in the next video how to declare a pointer to a member function. Okay, so slight changes to this kind of declaration. And then how we can use pointers to members, and how I've used pointers to members in particular in the case of constructing all of these new functions. I added to our string class for search replacing. So you're going to find that through the use of pointers to members and pointers to functions, there is only one implementation function for all of these functions. So there's only one place to look for any possible mistakes, and I'll get to that next time. Okay, see you. I forgot to mention one thing. This thing, if you don't want to use a type def, the declaration would go this way. The variable names would go in the place where the type def identifier would have gone, and the value that it's assigned to on this side. So this should, I want to save that content. I just want to keep it. Second. Oh, I can save it in Unicode. Unicode. Did I say Unicode? Code, right? Yeah. UTF-8. Unicode. UTF-8. That's what I want. Thank you. So as you can see, it compiles just the same. And these can sometimes be difficult to read. That's why typedef is often the way to go with this sort of thing. It's hard to tell that this is the thing being assigned, that this is the value, right? And this thing is not an int star, right? It's a pointer to a member of my struct which has type int star. So it doesn't read very clearly. It's better to use typedef if you can. Oh, I'm not using the mic. If you didn't hear what I just said, this is not preferable over the typedef. Use a typedef instead. This is less clear, even though it has the same meaning. This is the thing being assigned. This is the value being assigned to. This is not the type of this. It is the type of thing that this through this would refer to. So I wouldn't, that's not so clear. Okay. Sorry.